Hi, good everyone. Once again, welcome back to this channel. Hope you guys are doing okay. All right. Now, last class, I think we were looking at sample mean. Was it sample mean? Was that the place we stopped? Yeah, we're looking at sample mean, and then we're looking at the population mean as well. So where we know the population, and from there, I think I started talking about weddings. Okay, and we're looking at okay, what about situations where you don't really know the population? So how do you get your mean? And we also looked at what makes your statistic closer to your parameter. Do you have more samples? Do you have lower sample? Do you need more sample size, or you need a less sample size, or a lower sample size, and all of that? Okay, in today's class, we begin to move into things that are more realistic. Okay, but of course, before we get here, we have to build those foundations that we've been building all this while till we got to this to be arrive at this particular point in time. So now the thing is that in reality, like I said, I tried to establish in the previous class, that the preceding class, that we don't used to know the population like usually. We don't used to know the population for one reason or the other. So now there is so how do we get the mean? How do we know how do we know a parameter if we don't really know the population? Do you understand? How do we get like the standard deviation, for example? How do we get the mean, for example? Like how do we just do all of those things? Do you understand? So now the issue is that in statistics and then in other stuff like that, we apply the use of a confidence interval, right? So we are going to be starting from a point where now, okay, let me put it this way. You don't know a population. Do you understand? The class that we did, we knew the population, so we calculated the mean, and then we calculated. I think we calculated the mean, and then we brought out samples from each samples of different sizes. Then we calculated their means, and then compared to the population mean to see how close they are. Do you understand? So now, but in reality, we don't have the population like that to compare with. Do you understand? So like we now statistics builds, statisticians came up with an interval, and then the interval is what they are going to use to be, sure to a reasonable extent measured in terms of percentages that okay, this value that we got, you understand, is representative of the population parameter, is representative of the parameter. So you have a range of values, and then they have a confidence attached to it. Okay, we are so percent certain that the parameter that we are looking for is within this set of values of the sample um, sample statistic that's corresponding to that parameter. Anyway, all of those things they come to follow the inferential statistics. So inferential statistics is a branch of you have descriptive statistics. They're just telling you when you have a data, it's just telling you how the data is. You understand? Okay, like what is the mood? What is the number that appears the most, right? What is the median? What is the mean? You understand? Is it normally distributed? Is it not normally distributed? All of those things, your bar charts, whatever, all of those things they fall under your descriptive stats. Try to like try to like just tell you, try to tell a story, based on the data that you've arrived at. Understand? Try to just describe it, like tell us the qualities of your data and whatever it is that you're doing. But inferential statistics goes beyond that. Okay, it's more of like, okay, why did you even have this kind of data in the first place? And are you supposed to even work with this data? Now, how because how can you make predictions, because now you're working with samples. Do you understand? So can you make predictions, can you make generalizations for the population that will be reflective of that population based on the sample that you have? So inferential statistics goes beyond just telling us it has one hand, it has one leg, it has this you know what I mean. It's like, why should it even be like this? All of those whys. Then okay, after we've gotten all of our things correctly, so can we use it to make predictions? So how good is our prediction going to be? None of those things. So they fall under inferential, statistics. Now, formally, inferential statistics is the branch of statistics that deals with the usage of data analysis to infer properties of an underlying probability distribution. Okay, is it normally distributed variable? Is it not normally distributed? Then you look at the underlying properties. I think okay, then the other thing that I said is that it's about how did I even put it? There was a way I put it in my notes. It's about data examination and prediction. Do you understand? It's about data examination and prediction. So it's not really about okay the qualities, like you examine the data, you understand, and then okay, when we're done, can we use it to predict how well can we predict with it. Now talking about confidence interval, there are a couple of things that we need to note. Then we have point estimates. Now, all the things that we've been doing before this time, they are point estimates. A point estimate is a single number. That's why it's called a point. You get it at the point. You understand? Just get at the point like this. Maybe 12. 15, 50, whatever, at a point like that. And then we got our population mean the other time in the other video as 80. That was a point estimate. So a point estimate is the value of a statistic that describes or that estimates a parameter. A point estimate is the value of a statistic that estimates a parameter. Do you understand? So like it's just a single number. So sample mean was 79.75. I think something like that. I think there was one I remember that was 80.25. Do you understand? So that was a point estimate, trying to like estimate a parameter, and the parameter that we eventually got to know it was 80. Do you understand? So like it's just a single point. All right. Now, what is confidence interval? Confidence interval is an interval of numbers. Can you see now? So it's not a point now. So instead of like this thing is here, I think it's between here and here. Do you understand? So like that's what confidence interval is talking about. Okay. So confidence interval is an interval of numbers that is obtained from a point estimate of a parameter. Okay, a confidence interval is an interval of numbers that is obtained from a point estimate of a parameter. So like something like a range of numbers. But I want to be careful with my language. It's an interval of numbers. So like it's instead of like just having 80 the other time, you can have a confidence interval of 79 to 81. Do you understand? We know our mean to be 80. Like one of them was 80, one of the sample means was 80. Like, okay, we don't really know this population mean. But then from what we've done is between 79 and 81. Do you understand? So like that's a confidence interval. A point estimate would have just been 80 on number. Do you understand? Okay. Then what is confidence level? Confidence level is the confidence that we have that a parameter is within a confidence interval. Do you understand? Like how sure are we? So if we say between 79 and 81, we can say that we are 80% certain. Do you understand? I think we got that. Yeah, we got that when we increase our sample size to 4 in the previous class. We got that. So like we are 80% certain that the parameter we are looking for, okay, which was the population mean at that time, population mean of the height of some basketballers or something like that. So that parameter we are looking for is within 79, like 1 inch away from what the actual population mean was, okay, and 81 is between 79 and 81. So that's the kind of thing that we're doing, in this particular, video. Then we have confidence interval estimate. We're just talking about the confidence interval and the level of, and the confidence level. Then level of significance. Level of significance is just one minus confidence interval. Now, confidence interval is between 0% and 100%. Do you understand? So, like confidence level of significance now is now 100% minus whatever it is that your confidence interval is. So, if your confidence interval is 95%, for example, do you understand? So, like your level of significance is going to be 5%. If your confidence interval is 95%, the level of significance is going to be 5%. So let me put it this way: level of significance plus confidence interval equals 100%. So let's just put it that way. All right. So there was at the beginning when we started talking about normality and all of those things, we add something like this. I don't know why I don't always draw this thing very well. And then we had our mean, okay, which we knew at the time. Do you understand? So like plus one standard deviation, then this u plus one standard deviation, u plus two standard deviation. Okay, let me just mu plus one standard deviation, then followed by mu plus two standard deviation. Then we can also have mu plus three standard deviation. Then the same thing on this side. Okay, mu minus one standard deviation, mu minus two standard deviation, and mu minus three standard deviation. And I was telling you then that one of the properties of normal distribution is that here, within two standard deviation of the mean, either to the right or left, do you understand? Either to the right or left, 95% of the observations are there. Okay, you have 95% of the observations within um, two standard deviations to the right or left. Okay, we got that. Then, all right. The thing is, actually, we also have for one standard deviation. So, for one standard deviation to the right or left, 68% of all of the observations are within standard deviation away. How do I even put it? You know what I mean, right? So A standard deviation away from the mean to the either side contains 68% of all possible observations, you know, of what you're looking for. Then here for three standard, I don't know, let me just do it like this. For three standard deviation, you have a 99.7% of your data sets, yeah, falls within three standard deviations the um to either side, of your mean, to either side of your mean. So I just thought, I should chip that in. Yeah, now what else are we supposed so like when we are looking at interval, so interval is like we don't know this population mean. We don't know this guy. Do you understand? So we are now like, okay, it is within, maybe we now have an interval of numbers, for example. This is just an example. I mean, we have an interval of numbers that says, okay, we think it is within whatever is here, whatever number you have here, and whatever you have there, something like that. So, and what to do is that we begin to apply our z-score. Now, there are two shades of this thing. We are looking at confidence interval with a known standard deviation. Okay, here we know the standard deviation. Do you understand? Now we are looking for the population mean. Do you get it? Now from a given sample, whatever. So we know the population standard deviation. Now we are going to move to a different part of it, which is like the next class, where we don't even know the standard deviation. And the funny thing is that, if not that it was for like pedagogical reasons, for teaching reasons, like how do you know the standard deviation of a population without even knowing the mean to start with? I don't know if you get what I mean. Because the formula for getting in a component of the formula of getting standard deviation is x minus, since we are using population, so it's going to be u, okay, s minus u squared, then over n, then you have this. So all of this thing will give you a standard deviation. So like, and you said we have standard deviation, but we don't know u. So it's not you that you're going to get first before you even get a standard deviation. Do you understand? But like, let's just start. Like, it's a building block. So let's start. Okay, we don't know our mean, but then we don't know our population, but then we know our standard deviations. Like, how do we approach it? The way to approach this is that we make use of our z-score table. We go back to our z-score table, and that's what we make use of to get the confidence interval. Do you understand? Now, when we don't have the standard deviation, when we don't know the standard deviation, we are also trying to estimate what the population mean. We begin to use our t table. So T-table is a different, thing on its own. It's very similar, it's very analogous to this, but there are slight differences. So begin to use our T-table. Okay. But whenever you know your standard deviation and you are trying to estimate a confidence interval of the population mean, you will be using the z-score table or the normalized um, distribution table, or something like that. Okay, or the standard normal table. All right. So let's just treat an example and then we see how it works. So yeah, you have this example on the board. Given the data below, find a 95% confidence interval. So we've been given a confidence interval for the mean age U of all people. So that's why I capitalized all people. So it's talking about the population. Okay, of all people in the Nigerian labor force, given that the population standard deviation of the ages is 12.1 years. So what we're trying to look for now is the mean age of all, you know, all the what do you call it, all people in Nigerian labor force, every one of them. And then you've drawn out the sample of ages, but then you want to use this to talk about the mean population mean of everybody in Nigerian labor force. Then we've been given standard deviation of 12.1 years. Like I said before, for you to get a standard deviation, obviously you must have known the mean, but like just for teaching reasons. So how do we approach this? So this 95% is simply telling us, okay, the formula to use to get the confidence interval. The formula is your sample mean, x by x, then minus z score. Okay, your z score, z alpha over 2, then times your sample standard deviation, which is your standard deviation for your sample for the mean by x, right? 2, then by x, sample mean, this is sample mean, plus z alpha over 2, then standard deviation of x. All of these things they are not hard. Okay. Now alpha is your level of significance. I was telling you that time. Alpha is your level of significance. I didn't tell you that it was alpha anyway, but like level of significance. So like you say that the whole thing is not hard. Now the mean. This is mean of the sample. So we calculate the mean of the sample. You understand? Add everything up. You have one, two, you have 10 times 5, 50. So your n, okay, we need that. Our n is 50, number of observations. Our n is 50, right? So like you add everything up, you divide it by 50, or you just use this formula, summation of fx over summation of f or over n. That will give you your mean. Do you understand? So you can do that one on your own. Like I'm not trying to do that in this particular class. So when we find out our mean is the whole thing when added together gives us 202069. So we divide this by 50, and then we have 41.4. 41.4. Okay. So now z score. So z score, our alpha confidence interval is 95. Confidence level, do you understand? Confidence level is 95%. Do you understand? So since confidence level is 95%, so our alpha would be 100% minus 95%, which is equal to 5%. Okay, and 5% is same thing as 0.05. Okay, so the z score that we're looking for is the z score at alpha over 2, which is the z score representing the area. Whatever number you have here is the area, it's talking about area. So we are looking for the z score that corresponds to the area that gives us 0.05 over 2. So we are looking for the z score that will give us an area of 0.025. Okay. The z score that will give us an area. So what we just do is you go to our z score table. Where are we going to have 0.025? You understand? Where are we going to have 0.025? So like we look for it, okay, we look for it, and then the z score that we're going to be having there, do you think it might be where is it? Where is it? Where is it? So the z score that we're going to be having there is 1.96. 1.96. Okay. Now let me just draw this. So from here to here is the 95%. Let's manage it that way. So, and of course normal distribution. So that means this and this are taking the 5%. So this will be taking 2.5%, 2.5%, and this one will be taking 2.5%. All right. So what we are looking for is when you convert to 0.5%, so we have 0.025. We also have 0.025. Okay, if you remember, your z score is to the left. Okay, if you recall, your z score is to the left. So what's you want to look at your 0.025 normally is under negative z-score values. Okay, if you remember, I told you then that your positive z-score values they start with an area of 0.5. I think that's like the lowest thing that you're going to find there. Okay, so 0.025 is under negative z-score values. Now, because you have 0.025 here, this is 0.025 area to the right. So what you're actually looking for in the positive z-score value is not 0.025. It is the total area, which is 1, the total area under your normal curve, and the horizontal line, which is 1 minus this. So I think we've done it before. So we have 1 minus this. You'll be looking for 0.975 in your positive z-score table. That's what I'm looking for. But in your negative z-score table, you definitely have this value there, 0.05. Thankfully, we did all of those classes, in the past. So what z-score corresponds to that? We are going to be having two z-score values. Okay, let me call this one like z1, and let me call this one like z2. Okay, so our z1 is minus 1.96. Okay, that's where I'm going to find it. Minus 1.9 under 0.06. And our z2 is just 1.96. Okay, so are we done? Do you have all the components of the formula? Then the standard deviation of the sample mean. Standard deviation of the sample mean. So how do we get standard deviation of sample? Recall that the standard deviation of the sample mean is the standard deviation of the population mean divided by the square root of observations. So that's where this guy comes in. I think we were given standard deviation 12.1 divided by root 50. So 12.1 divided by root 50, and then that's going to give us 1.71. Root 50 is 7.07. So this is going to give us 1.71 years. 1.71 years. Okay, so I think we have all of the things that we need. So our confidence interval at 95% is going to be by x, which we got as 41.4 41.4 minus 1.96 into brackets 1.71 to 41.4 plus 1.96 into brackets 1.71. Okay, so by the time we calculate that out, so our CI, our confidence interval, let me just write it in our confidence interval, just done, this is the final thing. So our CI is between 41.4 minus all of that. By the time you multiply, do everything out, you have 44.73 to the negative one gives you 38.07. So Z1 is the one with the Z1 is 38.07 to 44.73. 44.73. So we are 90, we are these are in years. Yes. So how do you interpret these results? So we are 95% confident, okay, because we started with 95% confidence interval. So we are 95% confident that the um, mean age of all people in Nigerian labor force is within 38.07 years and 44.73 years. We are 95% because that interpretation is important. I used to tell my students, very, very important. That's what differentiates what you are studying from mathematics. Mathematics ends here, or statistics mathematics ends here anyway. So like that's inference that I'm trying to make, that thing that I'm trying to talk about. So 95, we are 95% covered. There's a 95% confidence that the mean age of all people in Nigerian labor force lies within 38.07 years to 44.73 years. That's all. Right, that's all. So that settles that. So now the next thing that we are going into now is to calculate the margin of error. So what does the margin of error say? What does it mean? Margin of error is telling you how exact your what do you call it now? How exact your estimate is from the true value. Okay, how exact it is from the true value. Like it's just trying to give you a very, I think, have you done margin of error before? Just trying to like give you, like the limit, something like a limit. You understand? So your margin of error is like a limit. So like just tell you, okay, how exact is the estimate that you've gotten, how exact it is it away from your parameter at the end of the day. So how exact, like the estimate you've gotten now, which is like statistic, how exact is it from your parameter? So that's what your margin of error is saying. And its own formula is not hard. Margin of error is just this part. Margin of error is just this part. Z alpha over 2. Like it doesn't even take note of the sign. Okay. Does it, like it's just this number. Do you understand? Just this number, like this number. So Z alpha to their roots. And we may add the sign plus or minus, then whatever you have. I think that's how it works. Plus or minus, then this formula, apply this formula. So what we are doing essentially is Z alpha, then standard deviation of by x is just this part. So margin of error, let me erase this stuff. Margin of error is just this formula, Z alpha over 2, and this, so like equals Z alpha over 2, this part is the 1.96, then what we got here, so you have 1.96 multiplied by 1.71, like that's it. Just this part, so 1.96, 1.96, 1.71. And by the time we do that, we are going to get 3.35 or something. So the answer here is approximately 3.4 years. So margin of error is just telling that, okay, this is what your point estimate, you understand? But the limit to that point estimate that we must go for us to be able to like have the what do you call it now? For us to have the population, the parameter that we're trying to look for is just 3.4 years. So like looking at it, we are saying that how do I even say this? By the time you do 44.73 years, minus where's our mean? So these are our mean 41.4. 41.4 plus 3.4 years plus you are coming to this side of the mean of your sample mean, it gives you 44.73 years approximately. Or you can just do this minus this, it will give you like 3.4 years approximately, 3.35 or something. Then this then your mean coming to the negative side of your mean minus 38.07 is also going to give you 3.4 years. So the margin of error is just something like you have your sample mean, which is 41.4. Sample mean is 41.4. So like if you have something like this, so your margin of error is approximately 3.4 years. So it is just telling that okay, going towards your negative hand side, most that you can go, the most that you can go is 41.4 minus 3.4. That gives you 338.07 approximately. Then 41.4 plus 3.4 gives you 44.73 years approximately. So this gap here and this gap here is also equal to your margin of error. Okay. So yeah, so that's that about it. So you can read more about it. You can read more about it. So the next thing is that what if our confidence interval was 90%? What if our level of confidence, our confidence level was 90%? So what does that affect? Of course, it doesn't affect other things. It only affects your C score. Okay, so we have B. No, don't let me say. Let me call this one C. Let me call this one B. So what's if confidence level was 90%? So if confidence level was 90%, it affects your level of significance. So alpha is going to be equal to 10%, and then alpha over 2 is going to be equal to like 5%, which is equal to 0.05. So by the time you draw, you don't really have to draw it all the time anyway. So by the time you draw it, you are saying that here is 90%, and this side have to share 10%. So here is like 5%, which is commensurate to 0.05. This part still is also 5%, which is commensurate to 0.05. So now on your z-score table, you have to be looking for uh, the z-score that corresponds with the area of 0.05. Of course, you probably already know the trick. Now, once you just look for the one that has the negative z-score, you understand? Once you get this one, it's going to give you a minus something. So like just remove the minus and then that gives you the corresponding value for the positive z score. Now what do I mean? Z1 here was minus 1.96. So definitely this one is 1.96. Do you understand? So whatever you get here now, it's going to give you minus something. So this one too is plus whatever number you get. So if you go and check your z score table and you are trying to look for 0.05 under the negative z score, you will be having minus 1.64. So the z score value that, like I said, Z 0.05 is saying this curve value that corresponds with the area of 0.05 or that has an area of 0.05. So here is the z score here. So now I can just put 0 here. So once I put 0, I've turned this one to a standard normal distribution, and everything I have here, they are z scores. So once you've changed your thing to standard normal distribution, so here I have minus 1.64, and here I have 1.64. Do you understand? So now what do I do? My bar x is not changing because nothing changed in my data set. My standard deviation tree is not changing, right? The standard deviation of my sample is simply, where's the formula? I think, have I erased it? Okay, standard deviation of my sample is standard deviation of the population divided by number of observation. Like those things don't change. So now what I'm just going to do is by x, which is 41.4. So I have 41.4 minus 1.64 into brackets 1.71 to 41.4 plus 1.64 into bracket 1.71. So what am I going to get? Is it going to be larger or smaller than the other one? So I have 30, for this second one, we have 37 to 40. no, not 37, 1.64, you have 38.6, yeah, 38.6. What did we get for the first one? 38.07. So we have 38.6. This is going to give me 38.6 to 44.2. 38.6 to 44.2. So that's what I'm going to get over there. 38.6 to 44.2. So this is now telling us that with a confidence level of 90%, so there is a 90% confidence that the um, mean age for all the people in the Nigerian labor force is between 38.6 years to 44.3 years. Obviously, you can calculate your margin of error from here. I've told you it's just this component. So margin of error, I'm not doing any calculation. Margin of error, we are running out of time. So margin of error from there, did I even solve it here? Is I don't know. I can't find it. 2.81 years. 2.81 years. So you have a margin of error of 2.81 years, and then you have a margin of error of 3.4 years. So which one do you think is more approximate? Which one do you think is more accurate? Which one gives you like a more accurate view that okay, whatever value you got is this close to the population mean? It is the second one. So what you got is 2.81 years close. Do you understand? To the actual population that you're looking for. And this one is saying it is 3.4 yes, no. So like, what you can deduce or what you deduce from this is that the more the level of confidence, the more no, how do I no, the lower the confidence level, you understand, the more accurate the result is. That is what this is telling us. Okay, the lower the confidence level, the more accurate the result is. All right. The same thing. Yeah, yeah. That's just the point essentially. That's just the point. Yeah, that's just the point. So like I think the other thing that you could just do on your own, I've already compared the margin of error and I've already compared the confidence interval. So which one is more accurate? Of course, the one with the lower margin of error. You understand? And if you were to draw, let me leave a space for that. Um, if you were to draw the two confidence intervals, let's say you have a question that says compare the two confidence intervals. If you were to compare the two confidence intervals, so the first one um, which was at 95%. Okay, you had 38.07, 38.07, and then 44.73. But now, the new one that you have is having a 38.6, which is closer to the mean, and then it's having a 44.2. 44.2 is inside of this, 44.2. So when you draw it out, so you have something like this, 90%. So if you are comparing, so this is more accurate because it gives you something much more closer, okay, to what um, the population mean is going to be. You understand? Okay, so you're 90% confident that it is within. So this is like try to restrict. Like I'm almost sure of myself. I'm 90% confident that it is. It is not this much. It is within this place, within this small place. So which is a pretty good thing. All right. So I don't know. I think I'm supposed to have an assignment. Yeah, exactly. Does it want to kill us? Like what? Okay, so assignment 1A, determine the sample size needed in order to be 95% confident that the population mean is within 0.5 year of point estimates. Is within 0.5 year of or years of the point estimates. Recall that standard deviation of the population is 12.1 years. So we are just still talking about the example that we did. I didn't just want to give you something like that. It's exactly like that because I thought it to be very, very, I don't know, very, very easy and you might be bored. You understand? I know you guys are very intelligent people. So like to give you a hint, so what you have to do is obviously you know what within 0.5 years of point estimate means. You know what statistic that is talking, you know what variable that is talking about. So you look for or which of the formula that we've done, in this particular class, which of it relates, sample size to this to any, you know, so anything here, I don't want to just say directly, so that at least you put your brain to, a very good and challenging task. Now, when you're done with that, so find a 95% confidence interval for the population mean if a sample of the size determined in part A, so going after the sample size I determined here, if has a mean of 43.8 years. So if based on the sample size determined in this place, okay, and then that sample size happens to have a mean of 43.8 years, then look for the confidence interval. All right, number two, suppose that you have obtained the data on your own. Maybe you're carrying out your project now. Suppose that you have obtained a data um, by taking a random sample from a population, and that you intend to find a confidence interval for your population mean. Okay, so before performing statistical inference, what should you do? So before you begin to solve for confidence interval and whatever, what should you test first? Yeah, so that's what it's asking you. What should you test for? What should you look at? Yeah, we are looking at data like this. Guy, what should I first do before I then begin to like start to write and everything and start to calculate and all of that? The answer to that, you'll be needing it in your final project. Honestly, to be very candid with you. So it's one of the tests that you're going to be carrying out. And then why are you carrying out that test? So B, maintain a confidence level of 95% or 99%, which will give you a more accurate estimate of your population mean and why. I think this is probably the first thing you're going to answer in all of these things. It's so simple. Okay, so that's a wrap. So in our next video, we'll be looking at confidence interval with no known standard deviation. There is no standard deviation. It's very, very simple. Yeah, see you there. But before we go, make sure you download your T table before we get to that particular video. You'll be needing your T table there. Thank you.